So I'm doing a quick revision of first 4 chapters here. I'll go very fast. So network goals, local area network, size, transmission, each machine is statistically independent, wide area network, a country or a continent, uh, wireless network, uses of computer system. Then you have network topologies in which you have star topology, expansion is easier, you have bus topology, you have a backbone bus that connects everything, absorb, and you have a ring topology. That ends the first chapter. Then you have OSI versus TCP/IP reference model, protocol architecture, ISO. So function layer of architecture is secretary translator. This has to be done there. Data flow mechanism, data transmitted, discarded. The network router. Then you have interface relationship with a service provider. In the 7 layers you have physical data link, network data link, transport layer, session layer, presentation layer, and application layer. So physical data, network, transport, session, and presentation. Each layer has its own importance. Let me talk about the name again: physical data, network, transport, session, presentation layer. Session is like making a session, presentation is presentation, and application is the use of application. Then each layer is expanded in this chapter. In the TCP/IP model, you have application layer, transport layer, internet layer, host to network layer. So host to network, host first gives to the network, then internet, then transport, then application. Network specific routing, host specific, application specific. So you have host to network, router, host, application. The name here are internet, host to network, internet, transport, and application. So this is a very simple model, TCP/IP and a OSI model. I think you should have this one. Now, comparison of TCP/IP, OSI layer has 4 layers. OCI developed protocol over here. TCP developed after development of protocol. OCI both connectivity and connectionless services. So I'm copying this. So corresponding TCP/IP model, OSI model, presentation, session, transport, and network. Comparison of both the models. And we have physical layer. In physical layer, you have 3 things: twisted copper conductor, coaxial cable, and optical fiber. But these are divided into many. Also, you have to draw the spectrum. So extremely low, low, medium, high, very high. This is voice, radio, amateur radio, microwave. So even in simpler terms, you can start with radio, microwave, and citizen radio. Then you have got this symbol. Bandwidth is difference expressed in hertz. Bandwidth is low, propagation delay, distance to things and things like that. Then you have bounded media. The first is twisted pair. You have 2 copper lines. So they were popular telephone line. Energy flow is guided media. Metallic wire exclusively in telecommunication for last 90 years. 128 in length. Asymmetric 2i provides 1.4 Mbps network and about 60 from user to network. Then you have unshielded twisted pair. UTP is depicted in. So you have shielded twisted pair. Twisted pair has now unshielded. So twisted fate, twist of fate, unshielded twisted pair. Single pair, jacket, insulator, conductor. So this is the unshielded pair, and these are the 2. So insulator and conductor. Shielded pair, there are some utilities around the pair. So you have shield, that is called shielded. General properties of the gauge is the thickness, configuration, bandwidth, error performance, distance, cost. Then you have coaxial pair. Limiting factor to this cost phenomena is called the skin effect, as the frequency transmits the current flow in the wire. So to coaxial a very robust shielded copper in which solid core run coaxially around with this forms electromagnetic around the former serves greatly improve signal strength. So jacket, bread, shield. So remember that you are watching cable and you are eating breads. You cannot talk while you eat bread. So bread and jacket, you are also wearing a jacket. So bread, jacket, shield, center, and then you have optical fiber, secondary buffer, primary buffer, glass and glass. Glass shading, glass core. Then you so in the optical fiber, glass fiber, multimedia, multimode fiber, graded index multimode fiber. So optical system. The twisted pair advantages is that inexpensive, well-established design is sensitive to noise, coaxial, high bandwidth, long distances, noise immunity, physical dimensions, security is better compared to twisted pair. Connection cost very high, very high. So that was about the three modes of transmission. Then you have physical layer part 2, and this is wireless transmission, satellite and PSTN. So in wireless transmission, the first is understanding the radio frequency range of transmission. So you have radio, microwave, infrared, X-ray, gamma ray, twisted pair, coaxial, microsatellite and fiber. Omnidirectional direction antenna to broadcast this. Very low frequency, microwave transmission. This diagram could do in microwave transmissions, where you can have this and building. And you have microwave bands, analog, digital, distance security. Then you have satellite communication, satellite. You have C band, KU band, Ka band. K is an important word here. So C is TV broadcasting and mobile voice, which is K band, which is 30 to 20 megahertz. There is C band, which is TV, and this is direct to home is 14 to 11. So you have C, KU, KN. So that would work as your upstream downstream satellite frequencies. Satellite, this will also work. This will also work. So, but this diagram is important. So I'll take this. Then you have C band, radio band, KU band, global position band, KA band. Then you have telephones, mobile telephones, cable television, which are not very important right now. Then you have networking devices. So if I skip this, because this is very new, I think it's better to skip this and move to the next chapter, which is multiplexing. You have frequency division multiplexing, time division multiplexing, code division multiplexing, and spectrum, wavelength division multiplexing. So frequency, wavelength, time, and code. Modulation, you have amplitude modulation, frequency, and phase shift modulation. Amplitude, frequency, phase. These are both for digital and common. And multiplexing is frequency division multiplexing. So multiplexing, whenever you have multiply, you have to divide. So frequency division, time division, code division, wavelength division. Again, this would be helpful only for two numbers. So frequency division, time division, code division, and I think this would do it. Now you have data link layer. This is the first one. So the data link layer, just remember this: physical, data link, network, transport session. So you are in the data link layer. Framing, flow control, error detection, redundancy. So you have VRC, LRC, CRC checksum. So vertical and longitudinal, cyclic redundancy test and checksum. Original data, cyclical redundancy test, and this would do it. Then you have data link protocol. So elementary data link protocol. So we are in the data link protocol elementary: positive acknowledgement, sliding window repeat. Then protocol verification. Finite state machine, Petri models are used to indicate transition from user 4, denote circle, transition from. So after transition each of at least one token input, any level is fired and token of input above is stored in output place. After firing, token may depend vary upon the number of input. So example of data link plan: high level data link, point to point, PPP frame, multiple data. Then you have aloha and slotted alpha. Skipping this one. Then you have network layer. Network layer would have a routing kind of a thing. So network layer design, routing table, routing protocol. So router name, router address. This is the routing table. Then you have hierarchical routing. You have distance vector routing, hierarchical routing, interior exterior routing, hierarchical distance vector routing, link state routing, and digest algorithm, that is shortest path. So that was quickly about routing. Then you have network layer in the internet, so IP4 addressing. So version ISDL, IP internet protocol header would be something like this: version ISDL, type of services, total length, identification DMFF fragment, time to leave, protocol headsum, source sum and destination. This is important diagram. Then you have transport layer. Service provider upper layer, quality of service, transport service, simple transfer layer, example of capacity, example of finite state machine. Error control, listen, finite state machine, waiting queue, establish, sending, receiving, listen, disconnect, send, receive. So this is the finite, this is in the transport layer. Then you have UDP and TCP. Corresponding UDP and TCP, this is in the transport layer. You have application layer. Application layer is something where you can write about the most. Then you have session layer and presentation layer. Session layer is transport, dialog management, activity and synchronization. Session layer synchronization. So dialog manner synchronization, major synchronization. Presentation layer design issue, translation, ANS, abstract notation, encryption, decryption, authentication, and things like that. Then you have network security. So network security, you have got network security, data security, security test, data encryption, transfer encryption, and data. So here in network security, you have viruses and worms, Trojan horses, spam, packet snippet, malicious sources. In data encryption and translation, you have ASCI, EDBIC. EDBIC, you have plain text encryption, public private key, ciphertext, and design. So asymmetric and symmetric encryption, you have plain text encryption algorithm, public transport key, decryption algorithm. Then you have encryption, secret key, ciphertext here. Then you have data compression, finite set. Then you have cryptography, substituting ciphers. Then you have security for substitution cipher. Then you have transposition ciphers. So that was a very quick revision.